Okay, so this is the first lesson of our last unit involving quadratic relations. After this, we are moving on to a brand new curriculum stream. In 6.1, we're talking about solving quadratic equations. So up to this point, we've been working on maximizing or minimizing quadratic relations. And so here are 3 examples of quadratic relations. Okay, again, just to do a nice little recap, we know that they are quadratic because they are second degree. That's what this guy tells us here. Okay, these guys all happen to be in standard form. This one has a y-intercept of 0. This one also has a y-intercept of 0. And just by sheer coincidence, this has a y-intercept of 0. This guy opens up, this guy opens up, this guy opens up. They all have minimum optimum values. We don't know what those optimum values are. Okay, so that's one of the downfalls of standard form, but these are relations. They equal y. With unit 6, we see the introduction of a quadratic equation. A quadratic equation does not equal y, it equals a number. So if I were to replace y with the number 0, or here, if I were to replace y with the number 42, or if I were to replace y with the number -3, these have all become quadratic equations, okay? And that's really important to understand the difference. So let's focus on this guy for a second. This is a quadratic equation, okay? When we work with equations, we want to make one side equal to 0. So I'm going to ship that guy over to the other side. So I have 0 is equal to 6x squared minus 7x plus 3. Okay, and solving this quadratic equation means finding the value of x that makes the left side equal the right side. Okay, and that's kind of an idea that you worked on in grade 9. You solved all kinds of linear equations where you tried to find the value of x that satisfies the equation. Now it's sort of the same idea, except we're looking for the value of the independent variable that satisfies the equation, meaning when we solve for x and we plug it back into the equation, the left side equals the right side. So if you're someone that likes to check your work before you submit, this is right up your alley, because once we solve the quadratic equation, we can plop it back in and check our answers. Okay, obviously if it's a homework question, you're checking the back of the textbook. If it's a daily drill, you're checking the solution I provide. But in an assessment, this gives you an opportunity to check your work. Okay, so there are a couple of scenarios. Here we have a quadratic equation, again, because it's equal to 0, okay? And we need to find the values of x that satisfy this equation. So this one was given to us in factored form. If you are given a quadratic equation in factored form, all you have to do is set the factors equal to 0 and solve. So here x would be equal to -10, and here x would be equal to 8. Those are the solutions, those are the roots, those are the value of x that satisfy, sorry, I'm just trying to fix this, there we go, satisfy the equation, okay? Now let's check to see if that's actually true. If I plug -10 into here, I get 0 times -18, which is 0. That value of x satisfies the equation. Let's try the other one. Let's plug 8 in. Okay, I get 18 times 0, which also equals 0. These two values of x satisfy the equation. Those are the solutions, those are the roots. So if the equation is given to you in factored form, okay, nice and simple, we just set the factors equal to 0 and isolate x. In the next example, the equation was given to us in standard form. So if you are asked to solve a quadratic equation from standard form, you must factor that equation. And that's why we invested so much time in Unit 4, because factoring is such an important skill, and it's going to rear its ugly head in this unit. So here, using decomposition, we would be looking for numbers that multiply to -6, and add to -5. And those numbers are -6 and +1. So we recopy the first term, we recopy the last term and the equal 0, and we decompose this middle term into -6x and +1x. This is a nice little throwback to decomposition for you. Now I'm going to factor the first two terms, and I'm going to factor the next two terms. And these guys match, which is exactly what I wanted. Okay, and in the second bracket, we'll put the leftovers. Please be careful. We must copy equal 0 in every single step. We are solving a quadratic equation. This is not a relation. All right, now that we've taken it to factored form, we set the factors equal to 0 and solve. Bring that to the other side. Okay, and now I will leave this to you to do independently. If we substitute the value of x, 2, into this equation, the left side will equal the right side. Or if we substitute the value of -1/3 into this equation, the left side will equal the right side. And I suggest you try that. Again, it's an important skill to be able to verify your work on an assessment. Plus, this is one of the most important lessons for those of you planning on taking grade 11 functions. You must be able to solve quadratic equations. Okay, let's look at the next example. Here, this is also a quadratic equation. Doesn't quite look like one, a little sloppy. So if you run into a question like this, we can't jump into solving. We have to clean this guy up a little bit. So we're going to get rid of these brackets using the distributive property. And we're going to bring these guys to the other side of the equation. When we solve a quadratic equation, the equation has to equal 0 before we start factoring. I'm going to collect like terms. And now we're in business, okay? So we did one example where it was in factored form. We did one example where it was in standard form. This next example was just kind of a big, weird mess, but we've cleaned it up. We used the distributive property. We brought the terms to the other side of the equation to make it equal to 0. And now this is in standard form, and we can go about factoring it using decomposition. Once we factor it, we'll set the factors equal to 0, and those will be the solutions, the roots, the value of x that satisfy the equation. Here we go. Again, decomposition question. We're looking for numbers that multiply to -8 but add to 7. And those numbers are +8x minus 1x. If you would like a review on decomposition, you can go back to the notes I had posted earlier. Okay, I clearly can't talk and do math at the same time. There we go. Okay. These guys match. These guys are left over. And I was quite pleased when I marked your factoring test, so I'm confident that you guys will be able to bring back those decomposition skills. Okay, so we've factored the quadratic relation. Now we're going to set the factors equal to 0 to solve the equation. Okay, I've said before, these ones are the most commonly made mistake among students. You have to be careful. A lot of times kids just want to tell me x is 1. No, it is not. We bring that over. So 2x is 1, which means x is 1/2. Okay? Now, I've completed 3 examples, and not once have I found the axis of symmetry. And kids are always dying to take these guys, add them up, and divide by 2. But you have to make sure you're doing what the question is telling you to do. We were trying to solve quadratic equations. Solving an equation does not involve finding a maximum or a minimum. If I had wanted that, I would have said, solve for the optimum value, find the max, find the min. That is not my goal in this lesson. In this lesson, my goal is to find the values of x, value or values, that satisfy the equation. And again, on your own, you can pause this video, Substitute x into this equation to make sure left side equals right side when x is -4. And left side will also equal right side when x is 1/2. Okay, so this next example looks a little bit different than the previous few. The first one we did, the relation looked like it was in factored form. Then we did one in standard form. I don't know if you guys see this. This guy follows the pattern of vertex form, okay? And so sometimes kids will say, well, miss, do we convert it to standard form so then we can factor it? You could, but that would take a really, really long time. That is not the most efficient way to go about solving this. So when the relation is presented in vertex form, the fastest way to solve this equation is to try to isolate x, okay? Which means this has to come over. So we're going to get -35 plus 8 equals -3 x plus 2 squared. And I hope this is starting to look familiar because you have used these skills in previous units, okay? This would be like the type of question where I say, find the value of the time when the height was 14, right? We did questions like this. Now it's the same method, just a different context. Okay, so that works out to be -27 is equal to -3 x plus 2 squared. Now I've got to divide both sides by -3. So +9 is equal to, oopsie daisy, x plus 2 squared. I got to get rid of the squared, which means I am going to square root both sides. Be careful, this is one of the most commonly made mistakes. When we square root 9, we get plus and -3 equals x plus 2. To isolate x, the +2 has to come over. So we're going to have plus or -3 minus 2 equals x. And then from here, we get two different answers. Okay, so we get +3 minus 2 equals x, and we get -3 minus 2 equals x. So x would be 1, or x would be -5. Okay, and again, both values will satisfy this equation. If I were to plug -5 into here, -5 plus 2 is -3. -3 squared is 9. 9 times -3 is -27. -27 minus 8 is -35. Both of these are the solution. Both of these are the root. Both of these are the value of the independent variable that satisfies the equation. So a much different method when we start with something that looks like vertex form. Okay, following along in the note here, I want to show you an example of a question that can be done given a diagram instead of an equation. So here it says for the graph to the right, okay, state the roots. Okay, the roots exist when y, can we see that? Yes, we can. When y is 0. So if y is 0, that means we're sitting right here on the x-axis. Okay, the roots. So in this particular example, the roots would be a -5 and a +2 because those are the zeros. Okay, we didn't need to crunch any numbers. We can read those right off the graph. Then it says, state the values of x when y is 10. So I go to my y-axis and I find the number 10, okay? When y is 10, the parabola hits twice. It hits once at -3 and once at 0, okay? So this is an added layer, another way that we can solve a quadratic equation, okay? We can solve a quadratic equation from factored form, from standard form, from vertex form, and then finally from a graph. Okay, the last example from the note, you're given a quadratic relation. It is in standard form, it's just not written in the correct order, and it's making me crazy. Oops, sorry, I gotta zoom this guy out. I apologize. Ooh, there we go. And so I'm really looking forward. I'm anxious to rearrange this guy, but we'll do that in 1 second. So it says, Mrs. Kerr throws a student's cell phone out of her window. Can you imagine the scandal? The path of the phone is parabolic, right? Shocker, because think about the unit that we're in. Its height in meters can be modeled by this equation, okay? How long will it take for the phone to fall 20 meters below its initial height? So this is kind of an interesting question. The first thing we need to do is identify what was the initial height of the phone, okay? And so if you want to crunch some numbers, the initial height would mean that phone hasn't been thrown yet, so you could substitute t into this equation, but I would hope by now that you know you don't have to pick up a calculator to do that. The initial height is 120, okay? Because if we throw 0 in for t, those terms get wiped out, okay? So if the initial height was 120 meters, and we want to know how long it took for it to fall 20 meters from its initial height, okay? So we've got this cell phone, started out at 120 meters. We want to know how long before it reaches a height of 100 meters, okay? So that means, I'm going to switch boards here. We are going to substitute 100 in for the height, okay, into the equation that we were given, and we need to solve that equation. So in order to solve an equation, it needs to equal 0 if we're working with standard form. This guy's going to come over, and when I bring that guy over, I'm also going to rearrange so that the terms are in descending order, highest degree first. So, oopsie daisy. So we have 0 is equal to negative 5t squared plus 21t, and now we have 120 minus 100, so plus 20, okay? Now, we have a quadratic relation in standard form, and so the way we solve, a quadratic equation in standard form, and we are going to solve this by factoring. I want to get rid of that guy first because he is bothering me. We don't like the coefficient of t squared to be negative. And there's actually another strategy you could use. What you could have done to avoid that negative is just brought all these guys to the other side of the equation, right? So this would have been the same thing as 5t squared minus 21t minus 20, okay? So if you'd wanted to do that, that'd be fine. You'd end up with the exact same answer. Now, this appears to be a decomposition question where we are looking for two numbers that add to 21 and multiply to negative 20. So we're going to copy the first term, we're going to copy the last term, and we're going to decompose that middle term. Those numbers are negative 25t and positive 4t. And again, if you feel like I'm going too quickly and you need a little refresher on decomposition, I'm happy to help, although I'm confident because most of you did very well on the test questions that involved decomposition. Okay, so copy, 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 factor these guys. So the common factor here is 5t, and we have t minus 5. Factor those guys, so positive 4, t minus 5, okay? And now what they have in common goes in the front, and the leftovers go at the back, okay? We're not quite there yet. So we have successfully factored this. We took it from standard to factored form. Now we have to set the factors equal to 0. So I know here t will equal 5, and here, just to minimize my chance of making a silly error, I'm going to actually show that work of setting the factor equal to 0. Like I said, all too often kids look at this and say negative 4. Well, that is simply incorrect. It's actually negative 4 over 5. Okay? So let's go back to that simple diagram I drew and think about the context of the question here. Okay, we have an object being thrown, a cell phone apparently, that belongs to a student, from a window, okay? So it was thrown from a height of 120 meters, so we have time here and we have height here, okay? And so it traveled in a parabolic shape. It reached a maximum height What is that maximum height? Gonna be honest, folks, don't know and don't care. They didn't ask me for it. That's not what this lesson is about. We're not interested in optimizing in this lesson. We are interested in solving equations. So it reached a max height. I don't know when, I don't know what, and I don't care. Then it hit the ground at, that's funny. Once again, I don't know because I don't know what the zeros are, but I do know, because I just did all of this beautiful work, that it reached a height of 100 meters after 5 seconds, okay? Did it reach a height of 100 meters twice? No, it did not, because it was thrown from a height of 120 meters. And that's why our other value of time happened to be a negative, because parabolas are symmetrical. Okay, so it's time to bring this already lengthy video to a close. I just kind of want to recap. So today we talked about solving equations, okay? We had no interest in the vertex. Not once did I find an axis of symmetry. Not once did I plug it back in to get the optimal value. That is not the point of today's lesson. The point of today's lesson is to solve a quadratic equation. If we are starting from a graph, we are happy. We can just read those values right off the graph, as we did in example 3 from the note. If the relation is in factored form, like it was in our very first example, we set the factors equal to 0 and solve. Okay, again, this one makes me happy because it is minimal work. All right, we're already comfortable setting factors equal to 0 and solving. The one little disclaimer I want to put in here is no axis of symmetry, because I've seen students do that on tests and quizzes, and then I'm forced to take off marks. We're not interested in the axis of symmetry here. We're interested in the value of x that satisfies the equation. If you are given an equation in standard form, okay, here we're going to take it to factored form, which we spent an entire unit doing, unit 4, folks. And then you're going to go back and do what you did up here. Set the factors equal to 0. That's why we're happy here, because here we don't have to do a ton of work. Whereas if we're solving an equation from standard form, we have to factor it and then set the factors equal to 0. From vertex form, we're not going to factor. From vertex form, it makes the most sense here to isolate x, to start bringing stuff to the other side of the equation. I've seen students convert this to standard form and then try to factor it, but those are the kids that run out of time on assessments. So you want to make sure you're very strategic in your choices. I hope that this video helped. By all means, do the questions in the textbook, message me with any issues you might have, and please, this unit, I really want you to return to the daily drills. I feel like the daily drills are very helpful and they really reinforce the same things you're going to see in the lessons. Thank you.